Weighing tens of tons and wrapped in layers of hardened armor, old military tanks were never meant to be taken apart. In this video on Factory Founder, we go inside the extreme industrial process that turns armored giants into raw steel.
For decades, these machines were symbols of power, protection, and destruction. Built to survive the most extreme combat conditions, military tanks were never designed to be taken apart. But when their service life ends, another complex journey begins. The process begins long before the tank ever reaches a recycling facility. Decommissioned tanks are carefully prepared at military storage depots.
I'm seeing significant corrosion on this link.
Yeah. Let me measure that gap again.
Okay, the camera's ready?
Yep. Adjusting the caliper now.
The rust here is extensive. Note that the hull integrity might be compromised in this area. Let's double check the optic sensors as well.
Fuel systems are drained, batteries removed, and sensitive components secured. Each tank is documented, its history recorded, and its condition assessed.
Noted. I'll add that detail to the manifest. Looks like we'll need extra abrasive to clear this section.
Initial visual inspection is conducted by multidisciplinary teams. Engineers, safety officers, and ordnance specialists examine the exterior armor, turret, suspension, and hull. They look for structural stress, hidden damage, and potential hazards. Rust patterns tell stories of moisture exposure. Weld seams reveal manufacturing techniques from another era. Every inspection note helps determine how the tank will be dismantled safely. The interior inspection follows. Access hatches are opened, and technicians enter confined spaces using portable lighting. Inside, they encounter wiring looms, hydraulic lines, control systems, and the remnants of military electronics. Even decades after retirement, tanks can still contain dangerous surprises. Fuel residues, lubricants, hydraulic oils, and coolants are extracted using sealed pumping systems.
Green hose is slowing down. Copy that. Monitoring pressure on the red. Check. All clear on blue here.
Only when the tank is confirmed fully passive can further work proceed.
Fire control systems are confirmed inert.
Weapon system neutralization is one of the most sensitive stages. The main gun, secondary weapons, and all firing mechanisms must be rendered permanently non-functional.
Slow and steady.
Noted. Engaging left unit.
Monitoring all systems. Lower into bins.
Next comes component stripping. External equipment, optics, antennas, storage racks, armor skirts, and rubber components are removed manually or with mechanical assistance. Tracks are detached, one segment at a time, using hydraulic breakers. Road wheels and suspension arms follow. The tank is slowly reduced to its core armored structure.
Keep it steady. Looking good. Connections are secure. Trays are in place.
Before cutting can begin, surface coatings must be removed. Military tanks are protected by multiple layers of paint and anti-corrosion coatings, designed to withstand extreme conditions. Abrasive blasting systems strip these layers away, revealing bare steel beneath. In complex areas, chemical stripping is used to dissolve stubborn coatings.
Keep an eye on the pressure. Level 1 is steady. Engage duct 7 now.
The result is a raw, exposed surface, free of paint,
Understood.
markings,
We
and
can proceed
identity.
with the next phase.
Now the most visually dramatic phase begins: thermal cutting operations. Armor steel is unlike conventional metal. Thick, layered, and hardened, it resists standard cutting methods. Plasma torches and oxy-fuel cutters generate extreme heat, slicing through steel plates centimeter by centimeter. Robotic arms follow pre-mapped cut lines, while technicians monitor heat, speed, and stability.
Tag scanned, updating inventory. Check the serial numbers on those road wheels.
The primary structure aligns perfectly with the schematics. Initiate the cutting grid at node 7. Affirmative. Securing the perimeter. Proceed with caution.
The turret is addressed first. Circular cuts separated from the hull at the turret ring. Molten steel flows into slag trays as sparks fill the air. Once free, cranes lift the turret away, a single piece weighing several tons. The hull follows, segmented into front glacis, central body, and rear engine compartments.
Keep it steady. Watch the clearance. Looks good from here. Slow it down now. Turret rotation complete. Systems confirmed 0 state. Proceed with solenoid cut. Cables capped. Stabilization clear. Keep it steady. Slowly, slowly. The markings are clear. Watch the clearance. Perfect.
Major section separation transforms the old military tank from a single machine into multiple massive components. Hydraulic spreaders push sections apart along cut seams. Cranes lift and rotate armor blocks with millimeter precision. Each movement is slow, controlled, and deliberate. One mistake could destabilize thousands of kilograms of steel. With major sections separated, secondary size reduction begins. Large armor blocks are further cut into manageable pieces. Guillotine shears, hydraulic presses, and additional thermal cutters reduce sections to dimensions suitable for shredding or melting. Internal reinforcements, ribs, and composite layers are exposed and separated. The metal now enters the shredding and sorting phase. Powerful industrial shredders tear steel into smaller fragments. Magnetic separators extract ferrous metals, while eddy current systems remove non-ferrous materials. Each material stream is isolated: steel, copper, aluminum, ready for reuse.
Keep it steady. Watch the wave. And right on schedule.
Melting and refining is where transformation truly happens. Steel fragments are fed into massive electric arc furnaces. Temperatures rise above 1,600 degrees Celsius. Impurities burn away. Alloy composition is adjusted.
Keep it steady now. Adjusting flow, almost finished.
Molten steel flows into ladles, then into molds, forming billets or slabs. What was once an old military tank becomes new industrial steel. Quality control is constant. Samples are taken from molten batches and analyzed in on-site laboratories. Chemical composition, tensile strength, and purity are verified. Only steel meeting strict industrial standards moves forward. Finally, the finished material is cooled, stacked, and packaged. Each batch is labeled and documented. The steel is loaded onto trucks or rail cars, ready for shipment to construction sites, factories, and manufacturers around the world.
Line 1 is cleared, ready for inspection.
Affirmative. Vacuuming is complete in Section B.
Check overhead cranes for positioning.
The process ends where it began, with transportation, but the transformation is complete. What once rolled across battlefields now becomes part of buildings, machines, and infrastructure. Recycling an old military tank is not simple destruction. It is controlled, methodical, and deeply technical. It is the intersection of engineering, safety, and industrial power. A final chapter for armored giants where history is melted down and reshaped for the future.